Using the Bronsted-Lowry definition, an acid is a compound that donates a hydrogen ion in a chemical reaction. There are several different types of acids. In this screencast, we are going to talk about naming binary and oxy acids. Let's first start with naming binary acids. How can we recognize a binary acid? A binary acid is a molecular compound that consists of a hydrogen and another more electronegative element. The name of a binary acid depends on whether or not it is part of an aqueous solution. If the binary acid is not in solution, it is present as a pure substance, and we use the general method of naming molecular compounds. For example, HCl gas is named hydrogen chloride. You may want to note that the most common binary acids involve the halogen family. When a binary acid dissolves in water, an aqueous solution forms that contains hydronium ions. As this solution is not a pure substance, we use a different method for naming the solution. First, write the prefix hydro, add the root word of the nonmetal, followed by ic, and then add the word acid. For example, the correct name for HF aqueous is hydrofluoric acid. Let's try a practice problem. What is the correct name for H2S aqueous? The correct name is hydrosulfuric acid. In contrast, H2S gas is hydrogen sulfide. Now let's move on to naming oxyacids. To understand how to name an oxyacid, let's first define what an oxyacid is. An oxyacid is an acid that contains oxygen. Here is a general formula for an oxyacid. The H represents hydrogen. The X represents a nonmetal other than hydrogen or oxygen, and the O represents oxygen, and the small a, b, and c represent subscripts. It is also important to note that an oxyacid appears to be composed of a hydrogen ion and a polyatomic ion, but it is actually a molecular compound, not an ionic compound. To name an oxyacid, first identify the polyatomic anion present in the formula. Next, change the suffix "ate" to "ic." Then add the word acid. Let's try a few practice problems. Please pause the tutorial and determine the name of each acid. To determine the correct name for problem number 1, first determine the name of the anion in the formula. In order to determine the anion, write out the ionization of the acid. Then, change the anion suffix "ate" to "ic." Therefore, bromate will be changed to bromic. Lastly, add the word acid after the name of the anion. For problem number 2, write the name of the anion. Rule number 1 states that you change the "ate" ending to "ic. However, for this oxyacid, the naming is slightly different. You add OR plus "ic." Therefore, the phosphate will be changed to phosphoric, and the final name of this oxyacid is phosphoric acid. You may recall that there are often polyatomic ions that are very similar to one another. We distinguish between these by using the "ite" ending instead of the "ate" ending. For example, SO3 is sulfite, and SO4 is sulfate, and NO2 is nitrite, and NO3 is nitrate. If an oxyacid appears to contain a polyatomic ion ending in "ite," we name it in a much the same way, but instead change the "ite" suffix to "ous" and then add the word acid after the name of the anion. Try this problem for practice. What is the correct name for H2SO3? In order to figure out the correct name, first determine the name of the polyatomic ion in the formula. The polyatomic ion is sulfite. Earlier in the screencast, we saw that there was a different method for naming phosphoric acid. When naming H2SO3, you must change more than just the "ite" suffix. Therefore, the correct name is sulfurous acid. Let's try 2 more practice problems. Please pause the tutorial and fill in the rest of the table. Now that we have reviewed naming binary and oxy acids, let's try a few practice problems. Please pause the tutorial and determine the correct name or formula for each problem. In order to write the correct formula for hydrofluoric acid, first determine the charge of the anion. When referring to the periodic table, a neutral fluorine atom has 7 valence electrons, so it must gain 1 electron to become a fluoride ion. Because the fluoride ion has a negative charge due to its extra electron, there must be a positive charge, a hydrogen cation, present in the compound to form a neutral compound. Therefore, the correct formula for hydrofluoric acid is aqueous HF. The correct name for number 2 is chlorous acid. The correct formula for hydroselenic acid is aqueous H2SE. Lastly, the correct answer for number 4 is hydrogen bromide gas.